Today we're going to look at our problem sets for distinguishing between circumference and area. For each problem, we're going to decide whether the circumference of the circle or the area is the most useful for finding a solution. For some reason, I'm over here. Move myself. There we go. So, a car's wheel spins at 1,000 revolutions per minute. The diameter of the wheel is 23 inches. You want to know how fast the car is traveling. So we're talking about speed. We're going to need distance divided by time. And that distance is going to be the circumference. And that's what it's like at school. Sometimes the phone just rings. So, since we need the distance, we would need the circumference. So, moving on. B, a circular kitchen table has a diameter of 60 inches. You want to know how much fabric would be needed to cover the table. So if we are covering it, that is area. A circular puzzle is 20 inches in diameter. All of the pieces are about the same size. You want to know about how many pieces there would be. So we're talking about, here's the circular puzzle. All of the pieces are about the same size. So, we're really talking about area. We're covering that. You want to know about how long it takes to walk around, the distance around the circular pond. How long it would take. Well, you would need to know the distance to figure out how long it would take. So that's circumference as well. The city of Paris is completely contained within an almost circular road that goes around the edge. Estimate the circumference of Paris and then estimate the area. So, here's our map. We see 1 mile. I pulled out a ruler. That's about 1 centimeter. Okay, so I know that I'm going to be looking at the distance across the circle, which is the diameter. And that's roughly 10 centimeters. Okay, so the diameter is 10 centimeters. That would mean the radius is roughly 5 centimeters. To find the distance around, that would be the circumference. So I would do pi times the diameter, which would be 3.14 times 10, which is 31.4. And that would be just miles. That's the distance around. Of course, it would be right on the circle, not like spaced out, but I just wanted to really illustrate that for you. Now, if we wanted the area, we would do pi times the radius times the radius. So 5 times 5 times pi. I think I'm estimating, I'm going to say 3 times 5 times 5 is 25, and I'm going to go with 75 miles square. Now we just roughly estimated based on this picture we had. I'm going to do a little research and see if we were close to the real thing. So it looks like we were quite a bit off, but if you look at the actual map over here, not really a complete circle. It's kind of a circular oblong thing. So that was fun, kind of good little context, but maybe not spot on with the way it worked out. That's okay. These are the answers that you should roughly get. Now, about how long is the fence? Okay, here's the diagram, infield, outfield. About how big is the outfield? So, the fence is going to go around the field. I wonder, okay, we're going to say the fence goes here, here, and here, all the way around it. So that's 250 and can't see. That's 250 here, 250 here. So to figure out the circular part, I'm actually going to have to use circumference, pi times diameter. No, the diameter would be 500. This is the radius. The diameter is twice that. So it's going to be 500 times pi. I'm just going to use 3 because I'm estimating that's going to be 1,500 for the whole circle, but I don't need the whole circle. I only need 1/4 of it. So I'm going to do 1,500 divided by 4. That's not going to be pretty, but we can work with it probably. 1,500 divided by 4, that is pretty. 375. By pretty, I mean we have numbers that are easy to work with. Just using a little slang here. Okay, so we have 500 plus 375 would be 875. What is this? Feet of fence. So around the field, the entire field, 875 feet approximately. It's going to be a little more than that because of we use 3 instead of 3.14. How big is the outfield? So this is a little trickier because we would find the area. Pi r. Now the radius is 250. 250 squared. We can do times 3. And we will actually do that over here in Desmos. 250 times 250 times 3. But I would need 1/4 of that because I have 1/4 of the circle. So I'm going to divide by 4. Whoops. So to divide by 4 with Desmos, I think I'm going to have to do this. Yeah. Divide that by 4 and I get 38,438. We're estimating, so I'm going to round there. Okay, so that gives me the entire part that is fenced in. This is the area of the fenced in part. But notice it only wants the outfield, so I would need to subtract the infield, the area of the infield. So the circular part, and we're just going to go with the circular part. Close enough. We're estimating about, okay. So the circular region for the area of it, pi r squared, the radius is 55 because the diameter is 110. 55 squared times 3. Let's go back to Desmos. And 55, again, squared times 3. Okay, so that's 9,075 back here. 9,075. I should put units on that as well. Feet squared. Area is always in units squared. So the final area of just the outfield, I just have one more operation to do. That is subtraction. So I would need to do this number minus this number. So I've got 38,438 minus 9,075. That's going to give me the area of just the outfield. Back to Desmos. Okay, 38,438 minus 9,075. And we get 29,363 feet squared. Here is the area of just the outfield. Okay, we're going to do a couple more. Here's a circular, it tells me on the page before, lawn with a row of bricks around the edge. The diameter of the lawn does not say. Looks like that was cut off with the picture here, so we can't really solve this problem. But what we can do, what's the best estimate for the amount of grass in the lawn? So the amount of grass in the lawn, we could say that's going to be area. So it's definitely going to be square units. But without any more information, which just happened to get cut off, kind of a typo situation, that's really all we can do. And the length of the bricks, or the distance around it, all we can really say is that would be in linear units. Because without any other information, that's really all we can do. and it just happened to get cut off. Okay, well, and this is a review problem. While in math class, Priya and Kyron came up with 2 ways of thinking about proportional relationships. So both students agree they can solve this equation to find the constant of proportionality. Okay, I agree. 5 times something is going to give you this. And she can solve it by dividing this number by 5, yes. And he can do it by multiplying by 1/5. Yes, because dividing by 5 and multiplying by 1/5 is the same. Okay, and just to kind of prove that real quickly, back to Desmos, let's do 1750 divided by 5, okay, or 1750 times 1/3. I don't know why I keep saying third, 1/5, divided by 5 times 1/5. So, same result. All right. So each person, back to this question here, each person would get, I think it was 350. Double check that. Yes. How are they related? I got that. So let's see. Priya would probably divide by 2/3. P-R-I-Y-A. And what would Kyron, if he started with this, he would probably multiply by 3/2 to solve. They would get the same result. I'm sorry that you couldn't see that as I was writing.